set, Jay, and judges? Not quite? Almost? Ready to roll? Ready? Okay. Yeah, you're okay. When I throw out the word cardboard, what immediately jumps into your mind? Is it a gigantic fridge box? Or maybe it's that UPS box that showed up at your door the other day with some tape, packing tape all over it and a corner bashed in? Or maybe if you're an engineering student, it's that piece of cardboard on the back that you notice that says it's time to buy some new engineering pad. Would you notice that? Well, you might be thinking, like, when I hear cardboard, I think of a bicycle. You're thinking, that guy has got a screw loose. You might be right, but as the CEO of Laminated Paper Vehicles Incorporated, cardboard bicycles are something I deal with on a daily basis. Back in September, we had a client approach us with a list of specifications. They wanted a vehicle that was 75 pounds, maximum weight. It had to be 90% paper, tape, and glue, and hold a 120-pound rider. This was a stiff set of requirements, and we wanted something that was simple, solid, would not fail. For that design, we needed our lead design engineer, Ross Willett.
The first thing we needed to do was go back and look at our previous generation model and figure out what exactly was wrong with it, all of the errors. So we went in, we figured it was too big, it's too tall, the ride height was just too much. There was a lot of friction in the steering column, very difficult to ride, and it was very complex to make. So we went to the whiteboards for brainstorming. The first thing we wanted to tackle was our Y-frame, the bottom bracket that holds everything together. Last year was made out of a 4-inch thick laminate that was routed, cut, grinded, and finagled into the right shape. It was really hard and very heavy. We decided to turn it into a 3-piece 1-inch laminate that sandwiches together fairly easily. It cut down production time and a lot of effort. We then moved on to our paper phase, where we took all of our parts and we laid them out. We gave them all dimensions. We did all of the fun geometric calculations to make sure that our pedals were not going to hit our wheel, they were not going to hit the ground in the corners, that we would be able to actually turn without frame interference. Once I had finished up all of these paper drawings, I passed them off to our CEO, Jared Schiff, for 3D computer rendering.
We actually used 2 parametric soliding modeling programs for this. The first one and the primary program that we did most of the bike and all the cardboard parts in was Autodesk Inventor. This was a fabulous way to take kind of our whiteboard drawings, the paper drawings, put them into 3D space, make sure this thing actually looked like we wanted it to. Our client wanted something that was aesthetically appealing as well as functional, so this gave us an opportunity to make sure this thing really looked cool. It also enabled us to check for interferences. We turned the forks, make sure our geometry didn't have any errors in it. You could do that in 3D space. It was really cool. We got our chain line all lined up. In addition, we were able to input density information of the cardboard, and we used Autodesk Inventor's density and material properties estimates to estimate the weight of the vehicle to within 5 pounds of its actual weight. We were also able to do finite element analysis on our parts. We didn't have data for cardboard, so we entered it as ABS plastic, and we looked at the high stress areas. You see some red on those pictures there, a little bit of green. Those are the high stress zones. We reshaped the fillets, the chamfers, where the holes were in the parts to minimize those high stress concentrations. For some of our parts, our aluminum parts, we actually had the right materials properties in there so we could put our factor of safety and make sure that thing was not going to fail. We also have a completely custom drivetrain. We needed our specific gear ratio. We didn't want to kite bicycle components. We got our gear sizes right. I spent some time in the machinist handbook. We got a SolidWorks model that meets ANSI 8 and ASME specifications for roller chain. We put it into FEA, stress tested it, worked out fabulous. We took it over to the machine shop. They CNC milled them on the spot for us. It was a kind of a quarter-long process. It worked out beautifully. We took it over to the weld shop, and the welding instructor did some fabulous TIG welding. Worked out beautifully. We have perfect drivetrain parts. Once we were done with our drivetrain, all of our computer stuff looked out really good. It was time to turn it over to our Chief Manufacturing Engineer, Chad Garrison.
So, as a CME, my main jobs were to actually collect materials from Sonico, company down in Sumner. They donated us some recycled cardboard laminate sheets. And these laminate sheets are about a 1/8 inch laminate sheet. And so essentially what we did is we took these laminated sheets at 1/8 inch, and we laid a layer of wood glue, sanded it down, and then sandwiched a whole bunch of them together. Just depending on what part of the frame, like was it 1-inch frame, so we needed to glue together about 8 pieces together. And then we put about 1,000 pounds worth of loading and let that cure for about 2 or 3 days. And then after that, it turned into this beautiful, just kind of like a model that we can start building and constructing our parts out of. And one of the main goals was to keep our bike very green and efficient. So what we had to do is optimize the amount of part layout on these laminates so we didn't have to, recycle so much cardboard. And as you can see, we did some calculations that we test fitted every single part, and it turned out we had only about 3 main pieces that were cut out. As you can see, all of us had the process of actually cutting out the materials using jigsaws, skill saws, and routers. And here's a sample of one of our wheels from a square. And after that, we just moved on to kind of the more complex type of components. As you can see, we have our upper crowns, lower crowns, sanding down the wheels so they'll be nice and round and smooth. And then we also installed some wood dowel steer bearings in our front forks, and that was very nice, easy steering for anyone to use. And then after that, we went into our dry fit process. We made sure all the parts came together very well and easily, and then we started doing our final assembly. And after we had all our final assembly done, all the glue's dried, everything looks great. Some issues did come up, unfortunately, and for that we headed up Jamie Gallagher, kind of the jack of all trades, to conquer these issues and hopefully get our bike on this race. So, Jamie?
Alright, so the first issue we ran into was our chain tension. It was not proper. It was very loose and loose fit. And this is a problem because when you're riding, the chain can easily pop off. And because of that, it would render our bike unusable during the race. So we spent some time at the local hardware store. We found some nylon bushings and a bolt. And this allowed us to tension our chain properly and ensure stability and durability. And then also our second problem was clearance between the chain and the wheel. It was rubbing. This caused unnecessary wear down on our vehicle. We wanted to create something that will last. And we fixed this by taking our wheel over to the angle grinder, and we just sanded it down, put it back on, and all of our clearance issues were fixed. And the main reason why we only had 2 issues on our whole bike was because we spent 3 months on our design phase. That's pretty much the exact reason we had so few issues. And we would also like to thank our sponsors, Sonico, for all their paper products, Bonnie Lake Bike Shop for helping us with pedals, Green River Welding and Machine Shop for CNCing everything for us, and then also our 2 helpers, Peter and Dita. Any questions?
Going once, going twice.
How much did your bike weigh?
59.1 pounds this morning. That was the goal.
And what was the paper? What was the non-paper weight?
We're at about 6.8% non-paper weight.
So we were very proud of that.
Yeah,
What was the total cost?
Actually, to us, all of our cardboard was donated. We spent about $200 on glue. The bicycle components were donated free. The chain came off of my bicycle, so it's pretty much all said and done. About $200 worth of wood glue and Gorilla Glue. That was the entire cost of the vehicle. And lots of hours of labor.
Lots of hours.
Lots of love.
8 months. So.
It doesn't come off at this point. Do we have any more questions? Okay, well, next time you want to buy a paper vehicle, please keep LPV Inc. in mind. Thank you.